Okay, now we're going to be looking at problems 17 through 20. These are a variety of different types of problems for you to look at. We see coefficients outside of the absolute value sign, which changes the way the graph appears, of whether the v is going to be very wide or if it's going to be very skinny. Notice that we also have a negative sign, which you should remember. It means that the graph is going to be upside down. It's not going to be a proper v. This graph is going to actually, instead of being this way, we know it's going to be upside down because of the negative v. The 2 is going to let us know if it's going to be a fat v or if it's going to be a skinny upside down v. So what you need to know is that if the coefficient is a whole number greater than 1, that your graph is going to be skinny. If your coefficient is less than 1, that your graph, your v is going to be very fat. So it's pretty much opposite than what you would think of. You would think a whole number means you're going to have a fat graph and a small number means you're going to have a skinny graph, but that's not how it is. If you have a number greater than 1, a whole number I should say, you're going to have a very skinny graph. The bigger the number, the skinnier it is. If you have a number less than 1, you're going to have a fat graph. So if you were to use a table and plot the points, you would see that the graph is going to be pretty fat. Here, it's pretty much like the other problems. You're going to see that now we have a combination of value inside with the x, which means what? It means it's going to shift on the x. We also have this outside value, which means we're going to shift on the y. So you're going to be somewhere along the x-axis, and the y-axis is going to be your vertex. So your vertex is going to be somewhere in one of the quadrants of your graph. The same thing here. We see some shifting on the x-axis, and we also see some rising on the y-axis. So let's get started. Okay, so here we go. Once again, the first thing that we do, first let me erase this. I'm going to erase these over here. So they're not in the way. Okay, so when we look at the graph here, number 1, we see the first step, like always, we have to see what makes inside the absolute value 0. What value of x takes the inside of this absolute value and makes it 0? And what are we going to say for that? We are going to say when x equals 2. So when x equals 2, this part of the absolute value becomes 0. That's what we want. Why? To find the vertex, to find that point. So that's one of the coordinates of the point. So if we were to substitute this into the equation, we would have y is equal to negative 2. Absolute value 2 take away 2, close the absolute value. Negative 2, absolute value of 0. Remember, this means multiply. This is being multiplied, okay, not added. If it was added, it would have an addition or subtraction number there. If it was being subtracted. Y, negative 2 is absolute value of 0, 0. So then, therefore, 0. Y is equal to 0. So my coordinate for my vertex is going to be x is equal to 2. Y is equal to 0. Okay? So then we're going to have our graph. One of these days I'll be able to draw this straight. And we're going to have x is equal to 2, y 0. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. So at 2, 0, which is right here, it's going to be our first point. Because this is a 2, this is letting me know that the graph is going to be skinny. But I want to show you why, so I'm going to take a second and I'm going to substitute values in there so that you can see why. So let's go and let's use red. Okay, so now I'm going to substitute values. So let's just say, I'm going to block this off over here. So let's just say I'm going to find out what happens when x equals 1. So when x equals 1, this equation is going to become y is equal to negative 2, absolute value of 1 minus 2. This is going to become y equals negative 2 times the absolute value of negative 1. Anything inside the absolute value becomes positive. So y equals negative 2 times 1. So y equals negative 2. So this coordinate pair is going to be when x is 1, y is negative 2. So when x is 1, y is negative 2. Okay? So now let's try 3 when x is 3. So I'm going to say y is equal to negative 2, absolute value of 3 minus 2, close the absolute value. Y is equal to negative 2 times 1. 3 minus 2 is 1. Y is equal to negative 2 times 1. So y is equal to negative 2. So my coordinate pair will be when x is equal to 3, y is equal to negative 2. So I will have 3, negative 2. And my graph, oops, let's just make this a little fatter. Pretend it went through there. Okay, that's what the graph would look like. And once we do this graph, you will see the difference between the width. Okay, so this is going to be the graph for negative 2, absolute value of x minus 2. With that said, let's jump right over here to number 18 so we can see what's going on over here. So first step again, what value of x? I'm going to use a different color. What value of x will make this inside the absolute value become 0? It's going to be 3. So we're going to say when x equals 3. So now we're going to solve it. Y is equal to 1/2. It's a positive 1/2, so we know it's going to be going upright like a normal v. And we're going to have 3 minus 3, which makes it 0, which is what we're always looking for our first point. Y is going to be 1/2. Absolute value 0. Remember, this is multiplication. So y equals 0. So I can say when x equals 3, y equals 0. That's going to be my first point. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3. 1, 2, 3. And we're going to say when x equals 3, y is 0. Let's give this another color. So when x equals 3, y is 0. That's that point right there. Now we're going to plot 2 more points. I'm going to plot when x equals 2 and when x equals 4 so that we can see if it's going to be skinny or wide. So we can see the effect that these have on the graph. So now I'm going to say 1/2. So now let's use x is equal to 2. So when x equals 2, I'm going to plug it into the equation. Y is equal to 1/2. Absolute value 2 minus 3. So y is equal to 1/2 times negative 1. This becomes y is equal to 1/2 times 1, which is therefore y is equal to 1/2. So when x is equal to 2, y is equal to 1/2. So when x is equal to 2, y is equal to 1/2. So therefore we should know when x equals 4, it's going to also be 1/2. And let's look at x equals 1. So when x equals 1, we should get y is equal to 1/2. 1 minus 3, which is going to be negative 2, which is 2. 1/2 times 2 is 1. Y is going to be equal to 1. So my pair is going to be, I'm going to have to move over here. X is going to be 1. Y is equal to 1. So we're going to have the pair 1, 1. So when x is equal to 1, y is equal to 1. And if I had this 5, it would be the same way. But as you can see, it's pretty fat. Okay? It's a lot fatter than this one. See over here? This is going to be a lot fatter. So the smaller, less than 1 of the coefficient outside of the absolute value, you're going to have a very wide graph. And when it's a whole number, you're going to have a pretty skinny graph. Okay, so the larger this number, the skinnier this graph will become. The larger the denominator in this graph, the wider that the graph is going to become. Okay, so I'm going to erase some of this. so that we can move on to the next problem without causing any problems. Let me move this here. I'm going to erase this. And there is a way to make this point fatter, but I don't know how yet. Okay, so I'm just going to move these out of the way. Okay, let's come over here to this graph here. So we're going to do the same thing once again. I'm going to change my color. We're going to go to blue. Once again, we have to find out what value of x inside this graph will make this equal to 0. And that's going to be when x equals -3. We're going to do that so we can find out what y equals so that we can get the point on the coordinate graph. Okay, I'm just going to erase some of this out of the way so we can graph it. Sorry about that. Okay. So now I'm going to plug it in and I'm going to say y is equal to the absolute value -3 plus 3 minus 2. So y is going to be the absolute value of 0 minus 2, which is the same thing as y equals 0 minus 2. So y is going to be -2. So when I draw the graph, the coordinates of my vertex are going to be -3, -2. That lets you know where we're going to be. So if I were to draw the graph, I should probably make this another color. And I'm going to draw my 1, 2, 3, 4. 1, 2, 3, 4. I'll put another one there and make that 1. So it's 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4. My vertex is going to be at -3, -2. 1, 2, 3, -3. Go down 2. And my graph is going to be like that. Okay, so this is very different. It's not on the x-axis. It's not on the y-axis. My vertex point is -3, -2. So you have to be very, very careful when you're dealing with these type of absolute value graphs. That's why it's crucial for you to understand what makes the value inside the absolute value 0, because that gives you your x coordinate for your vertex. Then you solve the equation by substitution and you're able to get what the y value equals. You plot that point. It's positive because there's no negative outside the absolute value, and there you go. Voila. So I want you to stop the video right now, and I want you to solve y equals absolute value of x minus 3 plus 1, and then click it back on and we'll have the answer ready for you. Okay, so turn your video off now. Okay, so here we go. What value of x will make this equal to, inside this absolute value equal to 0 will be 3. So we know x equals 3. We know that's going to be the first number for our vertex is going to be 3. We substitute it into the equation. We get y is equal to the absolute value of 3 minus 3 plus 1. Y is equal to the absolute value of 0 plus 1. Y is equal to 0 plus 1. So y is equal to 1. So my coordinate point for my vertex is going to be 3, 1. If I were to draw that, I'm going to have to squeeze it in here. I apologize. Here we go. 1, 2, 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. We're going to have 3, 1. 1, 2, 3, up 1. And this is going to be, I can't see it all, but this is going to be where the graph is. So my vertex is going to be 3, 1. Hopefully you got it right. Okay, I'll see you for the next 4 in a few.